This video is going to look at the liquid property known as surface tension. Our next physical property of liquids is going to be surface tension. And surface tension is the property at the surface of a liquid that allows it to resist an external force due to the cohesive nature of its molecules. More simply, we're just going to say it's how much a liquid likes to bead up, turns into a ball. So some liquids, as you pour them out, will stay flat, and other ones will start to ball up like you see with water, or some will even ball up even more like you might see with mercury. Surface tension is related to how strong the forces are that hold the particles together. So we have different particles. The stronger they hold together, the more surface tension there will be. We see that in the middle of the container, there are forces in all directions pulling those molecules together. But at the surface of a container, we see that those molecules are only being pulled down and in, and so that's why it starts to form this ball shape. But then there's the opposite force, which is just gravitational forces that make it want to flatten out. But the molecules inside of the drop will pull towards the center, and so that the whole thing becomes a curve shape. This means that a molecule in the middle of a liquid experiences attractive forces equally in all directions, and therefore has an overall force of 0. But particles at the surface of the liquid have a force that overall has a downward and central force, drawing it towards the center. For example, we see here that mercury has a very high surface tension, whereas acetone has a low surface tension. It's not nearly as spherical. And the strength of those bonds that hold these particles together will determine how strong or how much surface tension is present. The stronger the bonds, the more surface tension. One place that we see a lot of effect of surface tension is in water. So here we see some drops of water, and notice how curved they are to the point that they're almost curving underneath each other, getting a sphere shape. That tells us that the bonds between the water are very, very strong. In fact, the surface tension of water is one of the very, very important properties of water. And again, surface tension is found in all liquids. In the case of water, it's a fairly strong bond between the particles of water, and so it has a high surface tension. And that tells us that the higher the surface tension, that means that there's stronger bonds between the particles. You can think of that surface tension as similar to a thin layer surrounding the liquid, making it very hard to pass through. Certain animals use this to their benefit, so you'll see things like water walkers, and they can walk on water, and these bugs are able to walk on water because of the surface tension. So what they have is their legs have a lot of little fine hairs on them, and they spread their mass out over a large distance, and because of that, they're able to walk on water. Now, if they had their same mass and their legs were pointy, they would still sink in. We're going to see that same effect when we look at a paper clip. We can take a paper clip and float it on water as long as we set it on carefully and allow it to float on top. But if you poke it in with the very tip of the paper clip, it will sink very easily because, again, it's metal and we know its density is higher than that of water. And so to get it to float, we need to use that surface tension to allow it to float.